Okay, right now we are covering the laws of exponents. Okay? And what we're going to do is we're just going to go over problem by problem. There's only 3 laws. All right. So what law is being used? What property is being used in problem number 2? Which product? The product, the quotient. I'll put up here the 3 rules. We have the product property, the quotient property, and then we have the power property. So here's the product property. I have a to the power of n times a to the power of n. We're allowed to add the exponents. Quotient property. We have the same base. We're allowed to subtract them. And the power property. We are allowed to do what's called power to the power, and that's when you multiply. So which property is being utilized here? Quotient. Very good. So we're doing the quotient property. So all we have to do is do a to the power of 1.5, and we have to take away 0.9. And that gives us a to the power of 6. Now, if you wanted to put that in the form of a fraction, not a decimal, what is 6/10 reduced to? Yeah, 3/5. So I want you to understand. The answer is a to the power of 0.6, but you could also write it as the form of a fraction. Both of these are the exact same answer. All right? One's in decimal form, one's in fraction form. Okay? These are the same thing. Now, something we've had to do is we've had to change these sometimes to radicals. So if I wanted to change this from a rational exponent to a radical form, what number is going to go in the index? Yeah, 5. And then right here we would say a2. So every single option, these all are your equivalent. They all mean the exact same thing. All right, so we go over here. I think we already did this yesterday. I think we did B yesterday. So we're just going to move right over here to C. All right. So right here we have 2 over 8, which that's going to reduce to 1 over 4. Once again, which property are we going to be using? Quotient, that's right. So what do we have to subtract? We're going to do 11 minus 3. So I'm going to put it right up here so you can see it. 11/4. We're going to take away 3/4. These have the same denominator. So if they have the same denominator, we can do 11 minus 3, which is 8, right? But can I reduce 8 over 4? So we have 1m squared. Then this one's going to be a little bit trickier. We have 3/4, and what are we taking away? 7/4. 7/4. All right. So let's take it away. What do you got? -4 over 4, which equals d to the negative 1. So I'm going to put right here, I'm going to put d to the negative 1. Now that's not my final answer. Alright, my final answer, I don't have to put a 1 there. Okay? Because it's automatically assumed that there's a 1 there. But I am going to leave the n squared exactly where it is. I'm going to leave the 4 exactly where it is. But this d to the negative 1 equals 1 over d. So to make that negative exponent positive, I have to shift it down in the denominator. So that's your final simplified answer. So I want you guys to understand that this right here is not wrong, but this is the final answer that's completely simplified. Ooh, this one's different. Which property thinks being utilized in problem number 4? That's right. We have the power to a power. So this becomes a to the power of, if you multiply 5 times 1.5. Okay. That's right? 7.5. Okay, so 7.5. Now, you could keep it like that. Does anybody know what fraction that is? 7 and a half. As an improper fraction. 7 and 1 half. If I wanted to change that to an improper fraction. Multiply, add. We'll multiply those together. Add those, that's going to be 15 over 2. So you could also write a power of 15 over 2. Alright? We just leave it at 7.5. That's the power property. This one is also the power property. So what do we have to do with this power? We have to take this power and we have to distribute it to both of those. So right here, we're going to get 8 over 2, and we're going to get 24 over 4. But am I finished right here? Is that correct, Eric? Can I reduce those a little bit more? So what would my final answer be? X to the power of what? 4. And y to the power of 6. That's it. Okay. So you have to understand which property is being utilized. I think we did C together, didn't we? Did we do that? We did this yesterday, I believe. Okay, so I'm going to zoom out a little bit. Okay, and what we're going to do is we're going to do this table first, and we'll do this table. I think we filled in, this is dealing with rational exponents, then we're going to put this as a root, and we said that this was just the square root of 7. Now technically, there's a 2 here and there's a 1 here, but you don't have to write those in. Because anytime there's a radical and you don't see a number, you automatically assume that there's a 2. So this right here, we have to put this as a rational exponent. We got to put it as a fraction. Okay? What number do you think is going to go on top? 5. And the number that's at the bottom? 3. You're done. And then this one actually means 1 over e power of 3 fourths. So this is 1 over, and what number did we say went in the index right here? For this fraction? 4. And this is e cubed. Alright, so that number always goes in the index. This is always the power that's on the inside in the rad. So that's this table completely filled. Over here. Zoom in a little bit more. Like that. Alright. So here we go. This right here is the same as saying 3 to the power of 1/5. Alright, so Brian, what's going to go right in here? That's right, 5. And this is just going to be 3 to what power? 1, but we don't 3 to the power of 1, but you don't have to put a 1 because it's automatically assumed that that's 3 to the power of 1. Is that your answer? Say you were able to get this one done? I'll set it up. Put equals, this equals n to the power of 9 over 5. So what's going to go right there? 5, very good. This is going to be n to the power of 9. Alright, now this is correct, okay? But technically, I can simplify this a little bit more, alright? I want you guys to understand. What does n to the power of 9 actually mean? n being multiplied to itself 1, 2, 3, 4, 5, 6, 7, 8, 9 times. Okay? So just pretend like there's little tiny dots all the way, being multiplied all the way across. Okay? This index means I'm looking for groups of 5. 1, 2, 3, 4, 5. So how many groups of 5 do I actually have? 1 group of 5. So that is able to come out of the radical. So I'm going to make an arrow over here. So here's your final simplified answer. It's n times the fifth root of m, and how many do we have left in there that weren't able to come out? The power of 4. This is your final simplified answer. So this is where when you change it to a radical, when you change it from a rational exponent to a radical, sometimes you have to simplify it just a little bit more. This one's kind of tricky. All right, see, it's in the denominator. Okay, so this, if I changed it, would be 1 over c to the 7 over 3. Okay, that would be as a rational exponent. But you can also write it as c to the negative 7/3, which is the same as 1 over c to the power of 7 over 3. Okay, so that's what your final answer is for this one. So of all of them, I would say this is probably the trickiest because you had to simplify them around. Alright, so here we go. Now, this one right here, this property, well, that's quotient. These two are product properties. So what are we allowed to do with these fractions? Add them together, okay? It says we want to write our expressions involving roots and power. So we're going to change this eventually to a radical. Okay, the first thing we're going to do is we're going to add them together. So what do we have to add together? 1/2 plus 3/4. That's what we have to do first. Okay. Now 1/2 can also be rewritten as 2/4. Now obviously you guys have graphing calculators, so you can just use the graphing calculator if you wanted to. Okay. But up 2/4 plus 3/4 is a total of 5/4. Okay. So we're going to take x to the power of 5 over 4. Now we got to change this to a root or a radical. So what number's going to go inside the index? 4. This is. But how many do we need to find in order for something to come out? We need to find a group of 4. Is there a group of 4 inside of that? There is. How many groups of 4 are inside of x to the power of 5? There's only one group. So one group comes out. And how many left over? If you have x times x times x times x times x, and a group of 4 comes out, we still have left. We still have one x left. So this would be the answer as a simplified radical. This is the answer as a rational exponent. This is an answer as a radical. These right here are exactly the same. We have m, the power of 0.45, and we're adding 0.3, 3/10. So what does that give us when we add those together? M to the power of 0.75, right? 45 plus 30 is a total of 75. Oh, wait a second. What fraction is that? 3/4, right? 3/4, right? You get 3/4 at 75 cents. So here's what I want you to do. Change it to this. Using the same. Final answer. 4 goes in here. 3 goes in there. And you're done because nothing can come out. Because how many do you need to have? You have to have groups of 4. So once again, what did we add together? We added these together to get to this. Then we simply changed this decimal to a fraction, and then we changed it to a radical. Last one. Take away 3/4. And you can do this in the graphing calculator if you want to. I'm just going to do it right here by hand. Take away 3/4. So the least common multiple between the 3 and the 4, that's 12. So I gotta work in 12s here. Or plus. by 3, multiplied by 3, so it's going to be negative 9/12, multiplied by 4, multiplied by 4, that's 4. So it looks like my final answer as a fraction, if I take those away, is going to be negative 5/12. So I've got x equals negative 5/12. Now we got to make this positive. How do we make a negative exponent positive? What do we have to do? You have to make a reciprocal, right? So you're going to do 1 over x to the power of 5/12. So the last thing I have to do is I have to put it as a radical. So what number is going to go in there? 12. What number is going to go in here? 5. So this would be 1 over this. Now, technically, we're not supposed to have irrational numbers in the denominator, okay? So if I really wanted to have my final simplified answer, I'd have to do one more step. That's over 1. What I'd have to do is I'd have to multiply the numerator and the denominator by this. And I'll explain what the final simplified answer would be. So what we're calling this process right here, we have to call this process rationalizing the denominator. Okay, this is considered to be an irrational number. So in the denominator, this is left as x to the power of. Oh man, still nothing. Actually, I'm going to have to do one more thing. I'm actually going to have to put this as a 7. And this as a 7. Okay? Here's why. How many do I need? I need 12 of them, right? I have 5, so I need 7 more. Okay? So this times this gives me x, gives me this right here. What does that eventually become? Just x. So my final answer would be the 12th root of x to the power of 7. That gets a little bit tricky. All right, so we're not really in pre-cal. We'll make sure we get to simplifying radicals with crazy denominators. This right here will suffice for algebra 2. Okay, that will be your final answer for algebra 2. Your final simplified answer, if you're dealing with, what's the actual answer, right there. Okay. Now, in order to rationalize the denominator, we have to get these combined, and that's where it gets a little bit tricky. Okay. Now, right here, I want you guys to understand that I have a 64 to the power of 0.5 n over 4 to the power of a half n. We've got to find an equivalent expression. Are these bases the same? 64 and 4 are not the same base. Does anybody know how I could rewrite 64 where it's the same as this 4 to the power of 0.5 n? What can 64 be converted to? Remember that chart I told you guys to build yesterday? Look at your chart. What's it? 4 to the power of what? 4 to the power of 3. So I have 4 to the power of 3, and I got to multiply that by half. Okay? So I have to do what's called a power to a power. So what is half of 3? 1.5 n over 4 to the power of 0.5 n. So what was the first property we used? We used the power property. Now what property are we going to use between here and here? What are we going to use? The quotient property. Okay? So we're going to use the quotient property. So what are we going to do with those? We're going to subtract them. taking away half of an m. What am I left with? 1 m. 1.5 minus a half is just 1. So what's my equivalent answer to this? 4 to the power of n. Okay. Now let's think about this real quick before we move on. Get 16. The power of this. You gotta ask yourselves, right? If I do 16 to the power of a half times n, what is 16 to the power of a half? That's a 2. That's a 16. What's the square root of 16? 4. So what is 16 to the power of a half? That's 4 to the power of n. 16 is also known as 4 squared. If I take 4 squared and I multiply it by 0.5n, what do I still get? 2 times a half is still 4n. So this works, but guess what else works? This is equivalent as well. The only thing that's not equivalent is the 16. So you got to be careful. You got to make sure, are these equivalent, are they not equivalent? Okay? So that's equivalent, that's equivalent, that's not equivalent. Okay? So this one was the easy one to find. This one was a little bit trickier. And what did I have to do? I had to change that to 4 squared. To be able to do it. We'll do some of yours if you're on the board. Okay? So we have 7, and that's the power of 2n times 6 to the power of 2n. Okay, that's Andy's. Jacob, can you tell me yours? 81. 0.5. I'm going to put a T. That's right there. The divide or multiply? Plus 0.25, like that. Alright? Is that what it is right there? Okay. Alright? Now, what we're going to do right here is I want you to understand 81 can be rewritten as 3 to the power of 4. Okay? Now, this is a rule I would like you guys to put into your journal. Okay? I want you guys to put this rule, right? A to the power of n times b to the power of n is going to equal ab to the power of n. Alright? Which basically also means, these right here mean the exact same thing. So if I apply the power of n to both of those, this is a very important rule for you guys to have into your journal right here. Right? So if these powers are the same, if those two powers are, see how those powers are exactly the same? Then I'm allowed to multiply those coefficients together. So this becomes 42 to the power of 2n. Okay? So, if and only if this power matches this power, then you can multiply those coefficients together. What you guys are used to is the product property where the bases are the same, and you're allowed to do what? Take those exponents and add them together. But if the bases are not the same, okay, if these bases are not the same, but the exponents are, then you can multiply the variables or the numbers together. Okay? I'll do one more example, okay? Give me any number. 100. Okay, 100. I'm going to say that's the power of x times y. Okay? And then I have multiplied by, I'm going to put 2 to the power of x times y. These are the exact same power. So what can I do with the 10 and the 2? I'm allowed to multiply them together, so it's 200 to the power of x1. And that's how you could simplify it. Now I'm going to show you guys in the calculator that this works. Okay? So how about this? What if I said 4 to the power of 2 times 6 to the power of 2? So 4 to the power of 2 times 6 to the power of 2 is 576. Right? What's 4 times 6? 24. Look what 24 squared is also equal to 576. So it works no matter what. If the powers are the same, you're allowed to multiply those together. Right? All right. Now I need to go back to yours, Jacob. I gotta look and see what it asks me to do. All right, so I'm taking that from 3 to the power of 4, so I'm going to open this up right here, and I'm going to put 0.5t, all right, plus 0.25. Now what can I do? I can do the power property. So I've got to do the power property. So what's half of 4? 2. 3 to the power of 2t. And what is a quarter of 4? Like, what's 1/4 of 4? 1/4 of 4 is just a 1. That's your equivalent expression. So here's an equivalent expression. So you have one that says 9 to the power of t times 3, right? But this actually is 3 squared times t. This 9 is what? 3 squared times 3 to the power of 1. What am I allowed to do with those exponents? Add them together. So what I want you to understand is this actually becomes that. So that would be one of the forms that's equivalent. Right? So you have to really work basically. What I would do is I would work each one of them out and see which one's better.